to see exactly. So basically, the idea is to cut it kind of like similar to how this was cut, except not just like that, but like the whole thing. Because see, like when you cut this way, you see both ventricles and both atria. But imagine if you're cutting it like this, then you won't see both ventricles. You just see like the septum maybe, or if you cut like this, you won't see the same thing. So basically, what you need to do is you need to identify the front of your heart. And for that, you will be looking for like vessels. You also look for this shape, like the left ventricle goes to the bottom and the right is like this. So let's try on this one. And once you identify the front, you just basically will cut it like this. So you put it like that and you cut this one, so front part and the left part separate. And you can separate completely, or you can leave them attached at the tip so they can open like that. But anyway, so the most important, find the directions. So let's look at it. Also see how the auricles are. Auricles kind of like they're facing a little bit like this forward. So I think for me this is the front of the heart. And how do I know? See, like this is the sulcus. It's this one, interventricular sulcus. That would be the left side. That's the right side. That is kind of like my guess. Let's confirm it. So what I see here also, where's my, I keep losing this. Where's the probe? Oh, okay. Okay, thank you. So the vessels here, when I'm comparing them to the model, you can keep the model right next to it, just compare. So this will be the aorta, and this is the first. So like I said, these hearts are a little bit mutilated, so they cut off too much of vessels. So that's aorta, and you can put your finger in it maybe, or at least a probe. You can see this is the first branch of that's the first branch of aorta. So this part is aortic arch, and this one is that aorta. And then you see how this vessel, the pulmonary trunk, it goes over the aorta. So this will be the pulmonary trunk. And then here will be your right atrium on this side. All the vessels like these were really cut off, so usually I never see like these long ones, they just cut them off. And on the right side, you will have the right atrium. It's going to be here. So where is the vena cava? The veins, they're pretty thin, so that is the superior vena cava. So this is that. And inferior one, it's kind of usually folded. What I can do is I insert the probe in this one and come out through the bottom. So let's try. And see, this is the inferior vena cava. Again, it was cut off. If it's not cut off, sometimes it's longer. You may see it longer on your heart. It's going to be pretty thin. It's kind of like folded. It's hard to find it from the outside, but from the inside. So anyway, so we identified that's 100% the front. So what I'm going to do, I'm going to cut like this, basically, and separate into two. If your scalpel is not sharp, let me know. I'll get you a new blade. This one, not too sharp. It's okay. So try not to cut towards yourself. I know it's pretty strong walls. See, I cut through the left. I'm like in left ventricle now. I'm cutting through the tip and the septum. And once we cut it, we'll see the internal structures. So see, like the left is much bigger. And that's the septum. What actually meant not to keep it attached to the tip, but keep it attached at the top, actually at this base. But let's see. Let's first look like this, right? So we cut that was the front, and now we can see the right ventricle. We can see left ventricle. See this huge, big papillary muscle. These are chordae tendineae, and these are the valves. Same here. You can open like this a little bit because see the ventricle goes kind of like at an angle, so there's more surface. Of course, on the other side, the same thing. And we can cut a little bit more to open it further. It's just like when you cut, you damage the valves, so you don't see them as holes. You may see them first. How to find the semilunar valves? Semilunar valves, they're kind of like ventricles, they're convoluted. So what you can do, take your finger, like your pinky finger, and insert it, like here in this case. See, I'm going into the atrium. Like right now, my finger is inside the auricle, right? I can go through the vena cava, superior vena cava, inferior vena cava, right? But if I go into the ventricle is here, and I'm coming out through the pulmonary trunk. And my finger is too thick for this, but you can see where it's coming out. That's pulmonary trunk. So the valve would be like deep there, and you have to open more. By the way, this is an interesting structure right here. This is called moderator band. It's like a band of connective tissue that connects inside the ventricle one wall to another. That prevents overstretching. That's moderator band. But to see the valve, I would cut a little bit more, like this. Well, I'll just cut through it. And basically, again, like you have to look at it, so all kind of flexible, but like these are the flaps of the semilunar valve. And the way they work, they actually flex. They're very strong, but they're flexible. They work kind of like pockets, you know, like a pocket is like this. If you go down, the pocket opens and stops you. But if you go up, the pocket lays flat. So the valve is like several pockets, and the blood goes like this. It goes flat, but it tries to go back. It like catches it. So anyway, so basically that is the valve right there. See, that's one of the flaps. So if I go like this way, well, I mean, it actually, if I go like this way, it lays flat. But if I go backwards, see that? I don't know, it's hard to see. See that pocket right there? That's part, but that one on the other wall. So anyway, so that was a pulmonary valve, pulmonary trunk. That's pulmonary trunk right here. It doesn't have the branch point, so it was cut off about right here, this level. The branch point will be further down. I mean further up rather. But anyway, so on the right side, this is your. So on the left side, we had the bicuspid valve, tricuspid valve here, but this is bicuspid valve on the right side. See, this is one cusp, that's the other. These are chordate tendini. But aortic valve, again, you have to go like here, and see I'm coming through aorta. Aortic valve actually easier to see from this side. You can see those are the valve, three flaps, 1, 2, and this is the third one that was cut a little bit, but these ones are not cut. You can see them. So that's aortic semilunar valve. So what else you can see on the heart? All outside, I forgot to mention that you see, of course, same as on the plastic model. These will be the coronary vessels. They usually in the sulcus, it's not as distinct because it's covered by fat. You can see how fat goes. That's the interventricular sulcus. Here's the vessel, and these vessels, you can actually see them. You can insert a needle in it. And to me, when I first studied, like I first did ever looked at the heart, I was so like surprised because I read the coronary arteries, like that's your whole life depends on them. They are so thin, they are so tiny, you know. They are not like a huge big vessels. They're about as thick, like a little bit thicker than this needle, you know, these vessels. And if vessels block, that's it, you're dead basically. So, but anyway, so coronaries, they go like this. Why they call coronary? Because they go like this and they form kind of like a crown like that around the heart. So, and then the sinus is going to be on this side. So this sinus, you know, that is on the back, like this structure, it's on the back. So that's the front of the heart. Here is the sinus. Sinus is a lot bigger because see, it's much like that's a sinus. And don't use a needle because it's sharp, but you can use the probe and you can find the entry point to that sinus in the right atrium, and you can stick your probe, you will see it goes inside the sinus. See, like this? See, I found that hole and my probe is inside that sinus. And I can see where that opening is. It's kind of big opening. Also a lot of fat. This is not bad, this is normal. Heart uses triglycerides for energy, so it stores fat. It's not like a fatty heart or anything like that. It's like all hearts are like this. So, but anyway, what else is inside? So we have interventricular septum. The outside, we can like pick up the epicardium. That's like a little membrane here. See, like that's epicardium right there. Then, of course, this is all myocardium. And endocardium, again, it's like the membrane that covers everything on the inside. That, see, like that thin membrane I'm pulling up. That's endocardium. It's very important that endocardium in heart and endothelium and vessels, it's extremely smooth, because if it's not, the blood will start to clot, you get thrombosis. So any kind of damage to that is pretty bad, like if there's infection or something like that. And what else? And I think that's pretty much all the structures you have. You need to know 4 valves, you need to know 4 chambers, like myocardium, interventricular septum. See, in this case, you see left ventricle, it goes to the tip. This one is on the side. Even though it does go a little further, but it doesn't go all the way to the tip. And so that's it. And essentially, these are auricles. So auricles, I showed you, that's a left auricle, because that's the right side, that's left side. That's left auricle, that's right auricle. You can trace them by, like, if I'm in the left atrium, like my finger, I go through the valve there, and like, see, that's inside the auricle. Nobody really knows why we have auricles. They just like add to the volume of the atrium, but why not just have it smooth? But we basically have the auricles. It's part of the atrium. Well, that's it. So go look at your